This is a servo motor, which is tracking the cursor, and is always pointing its arm towards the cursor on the screen. Let's see how? We have a servo motor that is connected to the Arduino Uno microcontroller. The microcontroller is connected to the computer via a USB cable serially. Python code is running on the computer. The Python code will be responsible for tracking the cursor's position on the screen. This code will then calculate the angle and send it to the microcontroller via serial communication. The microcontroller will send the command to the servo to rotate the horn at the required angle. This is our first prototype. We have the cursor on the screen and the angle of the cursor. The servo is moving and following the cursor's angle. This is our second prototype. We have changed the background to yellow. Now it's easy to distinguish. And then we kept the servo on the box, to match the center point of the cursor, and the rotor of the servo. It looks like the horn of the servo is directly connected to the black line, but it is not. The position of the cursor is tracked via Python code, the angle with respect to the center point is calculated, and then this angle is sent to the microcontroller, which then sends a command to the servo motor, to rotate its arm. All this happens so quickly, that to the human eye, it looks spontaneous, and fluid. Then we zoomed in, to look at it more clearly, and compared the angle on the screen, and the angle of the servo, and the cursor's position. Then we thought of keeping the servo 180 degrees out of phase. So, if the cursor is at 90 degrees, then the servo will be at 270 degrees, and so on. It looks like the servo has an imaginary extension arm connected to it. Doing this was very easy, we just flipped the angle. That's all for now. See you again with more robotic technologies. Robotics every day.